All right, so if you've ever looked at the world of DevOps tools and just felt completely lost in a sea of logos and buzzwords, trust me, you are not alone. Today, we are going to pull that entire toolbox apart and build a really clear, simple way to understand what all these tools actually do.
I mean, that's the big question, right? It's overwhelming. You hear names thrown around like Jenkins, Docker, Kubernetes, Terraform, and your head starts spinning. But here's the secret. You don't actually need to know every single one. Nope, you just need to get a handle on the categories they fit into and the problems they're built to solve.
And look, this is probably the most important idea to get your head around before we go any further. DevOps isn't some job title you can get or a piece of software you can buy. It's a culture. It's a philosophy. It's all about bringing the development folks and the operations folks together so we can build better software faster. The tools? They're just the machinery that helps make that philosophy a reality. Okay, so here's our game plan. First, we're going to start with a big picture metaphor, the assembly line, to frame everything. Then we'll dig into the real foundation, code and containers. After that, we'll look at the automation engine that makes it all go, then the factory where it all runs, and finally, the watchtower that keeps an eye on everything. Let's do it. To make sense of all this, I want you to picture something with me. Forget software for a second. Imagine we're building a car on a super modern automated assembly line. This one metaphor, this is going to be our guide through this whole explainer. Think about it. Any assembly line has the same basic stages, right? First, you got to have your raw materials. For us, that's the code. Then you put those materials together and you check your work. That's our build and test phase. Once it passes inspection, you ship the final product out the door. And you're still not done. Finally, you have to watch how it performs out in the real world. Every single tool we're going to talk about today fits neatly into one of these 4 stages. Okay, let's jump right into the first part of our assembly line, the raw materials. I mean, before we can even think about building anything, we need a solid, reliable way to create, store, and manage our source code. And this brings us to what is maybe the single most fundamental concept in all of modern software, version control. You know, if you've ever had a folder with files named Final Report, then Final Report v2, and Final, this is it, I swear, you already get the problem. Version control is just the professional, grown-up way to solve that, creating a perfect history of every single change ever made. And let's be honest, when we talk about version control today, we're really just talking about one tool that completely won the war: Git. It is the engine that powers pretty much everything. It's what allows a whole team of developers, dozens, even hundreds, to work on the same project at the same time without creating total chaos. It's not an exaggeration to call it the bedrock. Now, here's where people sometimes get tripped up. Git is the technology, kind of like the engine in the car. GitHub and GitLab are the places you park your car. They're the web platforms that host your code. The easiest way to think about it is that GitHub is like the social network for code. It's amazing for collaboration and open source projects. GitLab, on the other hand, tries to be the whole shebang, an all-in-one platform for the entire DevOps process. Okay, so we've got our code managed. Awesome. But for years, there was this huge nagging problem. Well, it works on my machine. A developer would build something and it would break everywhere else. And then a truly revolutionary idea came along that just completely changed the game. And that idea was containers, with Docker leading the charge. The analogy is just perfect. Think about a physical shipping container. Any truck, train, or ship in the world can move it. A software container is the exact same thing for code. It packages up the application and everything it needs to run, all the libraries, all the settings, into one neat, tidy, portable box that runs the same everywhere. So we've got our code neatly stored in Git, and we've got our application packaged up in a Docker container. But how do we automatically connect those two things? We need the conveyor belt for our assembly line. We need an engine that puts the whole process on autopilot. And that is where CI/CD comes in. The full name is Continuous Integration and Continuous Delivery, or just CI/CD. Now, it sounds complicated, but the idea is actually super simple. Imagine this. As soon as a developer saves their code, a completely automated process kicks off. It grabs the code, builds it, runs a whole bunch of tests to find any bugs, and if everything looks good, it can even deploy the update live to users. All of it with zero human button pushing. And this is the job of tools like Jenkins, GitHub Actions, and CircleCI. They're the automation servers that act as our conveyor belt. Jenkins is kind of like the old, reliable workhorse pickup truck. You can customize it to do anything.
GitHub Actions is brilliant because it's built right into the place where your code already lives. And Circle CI is really well known for being super fast, modern, and easy to get started with.
Okay, our conveyor belt is running smoothly. We have an automated process to package our app. But where does this thing actually run? An assembly line needs a factory, right? And in the software world, our factory is made of servers, networks, and databases.
You know, back in the day, building this factory meant someone had to manually click through a bunch of web pages or log in the servers one by one. It was slow and prone to error. The modern way is called infrastructure as code. Instead of clicking, you write code that defines exactly what your factory should look like. This means it's repeatable, it's automated, and you can track changes to it, just like your application code. The two giants in this space are Terraform and Ansible, and they have slightly different ways of thinking. Think of it like this. With Terraform, you describe the end state. It's like giving an architect a blueprint and saying, build me this. With Ansible, you define the step-by-step instructions. It's more like a recipe. First, do this, then do that. You often see them used together. Terraform builds the house, and Ansible furnishes it.
Okay, we've used code to build our factory. But now we have a new problem. A good problem, but a problem nonetheless. Our app is a hit. We're not running one container anymore. We're running hundreds, maybe thousands of them, spread across a whole fleet of servers. How on earth do you manage that kind of chaos?
And the answer, for pretty much the entire industry, is Kubernetes. If Docker gave us the standard shipping container, Kubernetes gave us the entire global logistics system to manage all of them. It's the factory manager, the air traffic controller. It orchestrates all your containers, automatically handling scheduling, scaling, and even healing itself when things go wrong. It's basically become the operating system for the cloud.
All right, deep breath. The assembly line is built, our factory is up and running, and the product is out the door. But you can't just walk away, right? The job's not done. Now we need to climb up the watchtower and keep a close eye on everything to make sure it's all running smoothly. This whole area is called observability, and you can think of these tools as a team. Prometheus is like the network of sensors all over your factory, constantly collecting vital signs, CPU, memory, things like that. But a screen full of numbers isn't very useful, which is where Grafana comes in. It turns all that raw data into beautiful, easy-to-understand dashboards. And when you need to dig really deep, the ELK Stack acts like a super-powered search engine for every single message your application logs.
But here's the thing. Everything we just talked about is reactive. It's about spotting problems after they've already happened. True quality is proactive. It's about building quality into the assembly line from the very beginning. It's not something you check for at the end. It has to be a habit.
And an amazing tool for this is SonarQube. The best way to picture it is as a little automated quality inspector robot on your assembly line. It examines every single piece of code before it even gets built. It's looking for bugs, security holes, and something called code smells, things that might not be broken yet, but are probably going to cause a problem later. It makes sure our raw materials are top-notch from the very start.
So there you have it. From the raw material of code, packaged into containers, sent down an automated pipeline, running in a factory built from code, all while being observed from a watchtower, we've built the whole thing. The big question now is, what's next? As AI gets smarter and smarter, how much of this assembly line will one day run itself? Now that is a thought to leave you with. Thanks for watching.